Normal distribution is something that occurs naturally everywhere in the world. So there is a theory, it's called the central limit theorem. If you do something long enough, if you do an activity for long enough, chances are it is going to follow the normal distribution. The normal distribution usually refers to a special type of a curve. We have this, and we have a curve like this. If you notice, this looks like a bell, so that's why this is often called the bell curve. Now if you notice, most of the things is around here in the middle. So most of the things is here around the middle, and there is a very small quantity here at the higher end, at the upper end, and there is equal quantity at the lower end. So if you're considering about the height of people, most of the people, if you explore, you will see that most of the people height somewhere around here. Very few people are going to be so tall, 9-8 feet, that they're around here. Very few people. And most people, there are going to be very few people who are going to be so short, 1 feet or 1.5 feet, who are going to be here. In the world, most of the people fall around here. So this concept is the bell curve. And in the bell curve, one thing is very, very important, that the center of the data, the mean, is equal to the median is equal to the mode. So do you remember what happens if the mean and the mode and the median, the three central tendencies, when all three are equal, it means it has no skewness. This is very, very important note. The probability is the area under the curve. Now one thing about area is that area has to be a space. Area cannot be a line. Remember, a line does not have an area. If someone wants to find the probability of x is equals to 1, the probability will be 0, because x equals to 1 is like a line. So if you want to find the area from this region to this region, suppose from this point A to this point B, is the area from A to B of fx. Fx is the PDF, probability density function. So this is the probability, so, and it always has to be in terms of a range. So this is very, very important, and the area is found by integration. Of course, we do not have to do an integration. We have a table that is given at the exam. It's called the normal distribution table. Now one more thing that needs to be remembered is this is continuous. You have to remember, it is not discrete, it doesn't have separate values, it is continuous. For that reason, probability of x is less than or equals to a is the same as probability of x is less than a. Here there is no difference. If it was discrete, that's a big deal, but here no problem at all. All you have to do is remember that this is continuous, makes no difference at all.